Hello everyone, welcome to today's class. We'll continue with the questions of integration, the basics that we were doing. So this is a continuation of that. Okay, let's look at the questions. Integration 1 upon 1 plus sine x. See, 1 plus sine x, whenever you see 1 plus sine, 1 minus sine, 1 plus cos, 1 minus cos in the denominator, there is a good chance this rationalization would work. Okay, so if you look this kind of term, so just rationalize. Let's see. So this is integration 1 upon 1 plus sine x, okay, into 1 minus sine x into 1 minus sine x. Okay. So this becomes 1 minus sine square x, numerator become 1 minus sine x dx. So this integration become 1 minus sine x by cos square x, and it's a good thing because we can split the single denominator now. 1 upon cos square minus sine x by cos square. I can write cos x into cos x. Why? You'll see. What can be done here is 1 by cos square is sec square x. This sine by cos can be tan, and 1 by cos is sec. Okay, so minus sec x tan x dx. Okay, so now the integration of sec square is tan x minus sec x tan x, integration is sec x plus c. Okay, same idea. Start with integration of 1 plus cos x dx. So for this question, what can we do again? Same thing, rationalize. 1 plus cos, 1 minus cos, 1 minus cos. So numerator become 1 plus cos, denominator becomes 1 minus cos square, that is sine square x. Split it, so you'll get integration 1 by cos is, sorry, 1 by sine is cosec square x plus cos by sine sine. So cos by sine is cot x cosec x dx. So same idea as the above, same way you have to split. So integration of cot square is minus cot x, and this one integration is minus cosec x plus c. That's the answer. Okay. Now with the concept of rationalization, we can have like this also, sine x upon 1 plus sine x. Still the idea is same, 1 plus sine x. The moment you see 1 plus sine x, rationalize in the denominator. So integration sine x 1 plus sine x 1 minus sine x 1 minus sine x dx. So this becomes numerator. Now you'll have to multiply. So this becomes sine x by into 1 minus sine x. Let's keep it like this for now. Upon 1 minus sine square becomes cos square x, okay, dx. Sine by cos can become tan, but this is cos square. So let's multiply also. Sine x minus sine square x now upon cos square x upon cos square x. Let's see if that helps. This term can become tan square. We know how to integrate tan square. Again, we have to use a property. This one I can write sine by cos cos, no? So integration sine x by cos x minus this one become tan square. We can integrate tan square. So this becomes sine by cos tan sec x tan x, basically sec x tan x minus tan square. We cannot directly integrate, so we'll do sec square x minus 1. So because of this, negative sign will change dx. Okay, so now we can integrate. This integration becomes sec x tan x is, integration is sec x, sec square is tan x plus c. Okay. One more kind of variation in this concept of rationalization, sec x upon sec x plus tan x. Okay. Integration. Either you can go for the direct rationalization, or how will you see this as a rationalization? You can literally convert this into sine cos. This becomes 1 upon cos. Denominator becomes 1 plus sine by cos. Okay. Cos x cancels. So the question becomes effectively integration 1 upon 1 plus sine x. I think that was the first question that we did. Okay, so no need to do this again. Same as this question, first one. 1 plus sine x. So tan x minus sec x plus c. So I'm writing that directly. This is tan x minus sec x plus c. Okay. All right. Now let's look at another question. Sine raised to power 6x, cos raised to power 6x. Big numbers, big powers actually. Sine square x, cos square x. Now if you want to split, some power of sine will cancel, but the numerator and denominator will have different kinds of power. What I can think is one more variations can be possible. Power 6 is from cubes. Okay, this is sine square whole cube. Sine square x whole cube. That one is cos square x whole cube. I can use a cube plus b cube. So a cube plus b cube is a plus b. A square, that means sine raised to power 4x, b square, that is cos raised to power 4x, minus ab, so minus sine square x cos square x, and denominator is sine square x cos square x. Now this term is 1. Now sine raised to power 4 cos raised to power 4, we can rewrite this as sine square x whole square cos square x whole square. If only 2ab was there, we could have done something with it. Okay, so it's not. So let's forcibly generate this. If I write plus 2 sine square x cos square x, okay, of course it's not present, but what if we write this? If we write 2 sine square cos square, see we need actually minus sine square x cos square x, so we'll have to subtract 3 sine, we'll create some space here, 3 sine square x cos square x. Okay, so what I have done is I've written minus 1 as plus 2 sine square cos square minus 3 sine square cos square. Why? Because it will generate a plus b whole square again. If you look at the first three terms, a square plus b square plus 2ab, this becomes sine square x plus cos square x whole square minus 3 sine square x cos square x. So a lot of algebra is ongoing. Right now we have not used too much trigo. Now again, sine square plus cos square, it becomes 1. So overall this becomes 1 minus 3 sine square x cos square x upon sine square x cos square x. Alright, this was a whole under the integration dx. Okay. Now it's better, I think, if we split the denominator, this term will at least be 3. So this is the integration of 1 upon sine square x cos square x minus 3 dx. Okay. Now 3 can be easily integrated, that is 3x, and if you look at this question, this is something that we have already done. If 1 is there, what can we do? We'll substitute this 1 as sine square plus cos square. Okay. So if I write integration sine square x plus cos square x upon sine square x cos square x. For the timing, let's write down this as -3 only. We'll integrate it one step. Now split the denominator. So if we split it, it is sine square x by sine square cos square by sine square cos square. Okay, -3. Now this sine square cancels, cos square cancel. What is 1 by cos square? Integration sec square. This is plus integration cosec square -3. So now we can write the answer: tan x minus cot x minus 3x plus c. Okay. Lengthy question, but yes, that's the approach. We used a cube plus b cube, then we forcibly generate a square b square to ab, then we split the denominator, and then it was actually a question that was earlier discussed: sine square cos square. So write down the 1 as sine square plus cos square. All right, this is done. Let's go through more fundamentals. Integration, again same property is this: e log a raised to power, sorry, this question is just trying to confuse you. A log x plus e raised to power a log a dx. The moment you see e x log, you know that you have to get this in the power, get this also in the power, get this also in the power. So this becomes integration e raised to power log a raised to power x, this plus e raised to power log x raised to power a plus e raised to power log a raised to power a. E log cancels. A raised to power x plus x raised to power a plus a raised to power a dx. Standard formula: a raised to power x is a raised to power x by log a. X raised to power a is x raised to power a plus 1 upon a plus 1. A raised to power a is, it's a constant. What is the integration of a constant? Just multiply x with it. So a raised to power a, x, and plus c. Okay. Let's look at the next question. 2 raised to power x, 3 raised to power x upon 5 raised to power x. Single denominator. I think we have done it plenty for full questions now. So split it. So 2 raised to power x by 5 raised to power x, 3 raised to power x by 5 raised to power x. And then combine it. 2 by 5 complete raised to power x, 3 by 5 complete raised to power x. And now you can integrate. That's your a basically. Na? This is a log x. Okay. Sorry, a raised to power x. So the integration of a raised to power x is a raised to power x upon 1 by log 2 by 5 plus 3 by 5 raised to power x upon log 3 by 5. Okay. That's the answer of this. All right. I think we're done with the basics now. Let's move to the next category, that's AX plus B. All right. See, for ax plus b, I'll go through the formulas again. I've already created the formula sheet. So what you do is, see, compare. Sin x integration is cos x, na? So sin ax plus b. So if you replace every single integration by ax plus b, the integration pretty much remains the same. It's just that now you have to do a multiplication of 1 by a or divided by a. Okay. So whenever x gets replaced, you use the standard formula. Sin ax plus b integration is minus cos ax plus b, just multiply 1 by a. Similarly, cos ax plus b integration is sin ax plus b, just multiply 1 by a. Same with sec square, 1 by a tan ax plus b, cos x square, 1 by minus 1 by a cot ax plus b, and everything else. Okay. Look at this one. Suppose ax plus b raised to power n is there. So you consider the ax plus b part as some simple x. So the power will be increased by 1 divided by same power, and just coefficient of x basically comes out in the division. That's it. So all the standard integration results, that the 10 results that I talked about, are still applicable. It's just that now what you have to do is divide by 1 by a. Let's learn from the questions. You can refer to the sheet later. So if fx integration is, let's say, gx, okay, that's the overall sense of it, then integration of f of ax plus b will be g of ax plus b, same function, just that 1 by a will be additional. Okay, let's learn it from this example. 2x minus 3 raised to power 5 plus 1 upon 7x minus 5 raised to power 3 plus 1 upon square root 5x minus 4 plus 1 upon 2 minus 3x plus square root of 3x plus 2 dx. This will pretty much cover all the parts. So same thing, instead of x you have ax plus b, and the power is 5. So what do? Raise the power by 1, and additionally, what is the coefficient of x? 2. So that will come in division. That's it. Same thing here also. This power is minus 3, so it will become minus 3 plus 1, so minus 2. Okay. So 1 upon 7x minus 5 raised to power 2. Okay. Minus 2 will come in division. Okay. But this 2 is because of the power. Okay, negative 2, and coefficient of x will be additionally out. What is the coefficient of x? 7. So 7 will also be there. So 2 into 7 basically. Okay, same here also. What is the integration of 1 by root x? 2 root x. So 2 root 5x minus 4 is just that additionally coefficient of x, that's 5, will be multiplied here. So 2 multiplied by 5. Okay. Plus this one, 1 up, it's kind of like 1 upon x. Integration is log, so this is log of 2 minus 3x in the mod, and coefficient of x, that's minus 1 by 3, not just 3, minus 1 by 3, minus 1 by 3. And this is also done. Last, root 3x plus 2, I'll write here. So that will become 3x plus 2, power will become 1 by 2 plus 1, 3 by 2. So 2 by 3 because of the power, and then coefficient of x, that's 3. So into 1 by 3 additionally. So the rest you can solve, I think. You get the sense. You multiply these 6 and 2, 12. Okay. You multiply this 14, you multiply this 10. Okay. Multiply this, this becomes 2 by 9. Okay. So final answer, 2x minus 3 raised to power 6 by 12 minus 1 by 14, 7x minus 5 whole square plus 10 square root 5x minus 4 minus 1 by 3 log mod 2x 2 minus 3x plus 2 by 9, 3x plus 2 raised to power 3 by 2. that was the application of AX plus B. Okay, we have done one question. Now let's see another one. Integration of e raised to power 2x minus 3. Simple enough. Again, instead of x you have AX plus B. So e raised to power x integration is same, e raised to power x. So 2x minus 3, just that additionally you will have a division factor of coefficient of x, that's 2 plus c. Okay. A raised to power x integration is a raised to power x, so this will also remain same. Additionally you have division of log a, and remember to put down the coefficient of x. Okay. Let's look at few more questions. Get comfortable. Sec square 7 minus 4x. Okay. Sorry. So integration of sec square is, we know it's tan x, so tan same thing, 7 minus 4x, just that put down the coefficient of x, so minus 4 plus c. Then let's look at this. Sine, integration sine ax plus b cos ax plus b dx. Now what you can do is, actually this question can be done with substitution also, but right now we are learning the ax plus b format. Let's understand this. If I multiply this by 2 and divide also by 2, 2 sine a cos a is sine 2 times ax plus 2b, double of the angle, and upon 2. Now this 1 by 2 is constant, so leave it. So integration, what is integration of this? Integration of sine is minus cos 2ax plus 2b upon 2. Just put down the coefficient of x. What is the coefficient of x? 2a. So that will also come in division, so 1 upon 2a. So final answer minus cos 2 times ax plus 2b upon 4a. And that's the answer, plus c, of course. Yeah, plus c is there. All right. Based on this idea that we have done sine 2x property, no? Sine 2 theta is 2 sine theta cos theta. Let's take a look a few more questions. Integration sine 4x upon sine 2x. Then same variation, integration sine 4x upon cos 2x. Both the questions have the same idea. Okay. Let's look. I can rewrite this as sine of 2 times 2x sine 2x. Okay. And consider this to be a theta. So what is 2 sine 2 theta is 2 sine theta cos theta. So 2 sine 2x cos 2x upon sine 2x. 2x and 2x cancels. Integration of 2 cos 2x dx dx dx. What is integration of cos? That's sine. But coefficient of x will get in the division. So 2 by 2 sine 2x plus c. So answer is sine 2x plus c. Same thing here also. So this becomes 2 sine 2x cos 2x upon cos 2x. Cos 2x cos 2x cancels. So integration of 2 sine x integration is minus cos 2x and upon 2 plus c. So direct application of that sine to theta property. Okay. All right. Look at this question. It's looking like a lengthy problem, but after the manipulation of basic trigonometry, it will become simple. 1 minus 2 sine square x cos square x, okay, dx. High powers, denominator also has sine square cos square. The first step that will start is by factorizing this. This is a raised to power 8 minus b raised to power 8. So it will become sine raised to power 4 whole square. Na? So I'm using a square minus b square. So sine raised to power 4 whole square minus cos raised to power 4 whole square. Now what is this? A square minus b square. So I'm directly applying that. So that is a plus b, a minus b, sorry, a minus b, okay, upon 1 minus 2 sine square x cos square x. Okay. Now this is again we can factorize this, a square minus b square again. Yeah, so sine raised to power 4 x plus cos raised to power 4 x, that becomes sine square x plus cos square x. This becomes sine square x minus cos square x. Now still the denominator, there is nothing done as such. What I can do, if we look at this after doing some questions from the basics, we know that we can somehow change this 1 to something so that it becomes a whole square. No? This is 2ab, it's looking like this, no? 2ab. So what is this? So if this is 2ab, I want this to be sine square plus cos square, something like that. No? So what I can do, I can write down this one as sine square x plus cos square x, but that doesn't help. Okay, even if I write like this, it is not becoming any identity. Sine square x plus cos square x, this is not becoming any identity. So what I can do, instead of writing sine square plus cos square, I can write their whole square also, na? Because sine square plus cos square is 1. So sine square plus cos square whole square is also 1. Okay, now let's see what happens. Copy the numerator, lengthy one, cos 4x. I'll just put dash dash. Okay, there's no point in this, dash 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 dash. Okay, whatever the numerator is, I'm not doing anything with that. This, if we open this, this becomes sine raised to power 4x cos raised to power 4x plus 2 sine square x cos square x minus 2 sine square x cos square x. Okay, all right, same thing. If we look at these two terms, 2 sine square, 2 sine square, they are positive and negative, they cancel. So the numerator becomes now simple. So now denominator becomes simple. Denominator is simple, sine raised to power 4x cos raised to power 4x, and this is the kind of term that is already present in the numerator too. Sine raised to power 4x cos raised to power 4x. So yes, it's a benefit because it's going to cancel. What else we have? Sine square plus cos square. We know what is this. What is sine square plus cos square? 1. 1. Sine square minus cos square, there is no such thing as sine square minus cos square. Even if we apply a plus b, a minus b, still won't help. But what can we do? If we take negative common, that becomes cos square x minus sine square x, and that is something. What is that? That is actually minus cos 2x dx. Negative is already outside. I've taken negative common, so I've changed the sign. Cos square minus sine square is cos 2x. What is integration of cos 2x? That's minus, and integration of cos is sine 2x plus c, but remember to divide with the coefficient of x. So AX plus B format at the last step, but before that all variation of trig. Okay, all right, lengthy question. Okay, let's do a simple one. Not exactly simple. 1 minus sine x, okay, dx. I told you to rationalize, but if only it was in denominator. It's in numerator. What can you do now? Okay. Now you have to recall something from the last lecture. We did do one question in which 1 plus sine 2x was there. So I broke that sine 2x in half. Okay, so the idea is that sine 2x is 2 sine x cos x. And similarly, if I break sine x, it will be 2 sine half of the angle, x by 2 cos x by 2. Now why would that help us? I think if you revise that lecture, you will be able to recall what I'm going to do the next. I'll replace this one with sine square x by 2 plus cos square x by 2. What does this give me? This gives me a square plus b square plus 2ab, but point is which one? So this time the question does mention x belongs to 0 to pi by 2. Okay, that means it implies x by 2. Okay, so it implies x by 2 is from 0 to pi by 4, half of it. In 0 to pi by 4, which is greater, sine or cos? Cos is greater, so we'll write cos x by 2 minus sine x by 2 whole square, because we want our answer to be positive. Okay, so this becomes cos x by 2 minus sine x by 2, and I think after that the integration is simple. So integration is never really about the integration, it's all about setting the question into the form of integration where we can actually apply the property of integration. So cos integration is again sine x by 2, coefficient divided by coefficient of x, that's 1 by 2, so it becomes 2, minus sine x integration is cos minus cos, so cos x by 2 again 2 plus c, and that's your answer. Okay, all right. We did do the concept of rationalization. Let's do rationalization on rather than trigo, let's do rationalization on x square root of 3x plus 4 minus square root of 3x plus 1 dx. The moment you see square root, I think it is very easy to identify that we have to rationalize. Square root does give us the feel of rationalization. No? Let's rationalize. So if we rationalize this, okay, so I'll write down the step. 3x plus 4, this is inside the square root, this is also inside the square root, minus root 3x plus 1 into root 3x plus 4 plus root 3x plus 1, root 3x plus 4 or root 3x plus 1. So numerator remains the same, 3x plus 4, 3x plus 1 dx. Denominator is a minus b, a plus b. It becomes 3x plus 4 minus 3x minus 1. 3x cancels. You have a constant denominator now. I think after that the integration becomes simple. So you have to overall integrate the numerator part effectively. So what is the integration of root x? That is 3x plus, let's write down first, the denominator becomes 1 by 3 na? So I'll take 3x plus 4 plus root 3x plus 1 3 3x plus 4, 3x plus 1, and 3 I'm writing outside the integration because it's a constant, so let's take it outside. So 1 by 3. Now let's write down the integration of this. So power 1 by 2 means add it, so 1 by 2 plus 1 becomes 3 by 2 divided by 2 by 3, as well as the coefficient of x, don't forget that, so into 1 upon 3 additional, plus same thing here, 3x plus 1 raised to power 3 by 2 divided by 3 by 2 also, so 2 by 3, and additionally 1 by 3. So effectively if you take 1 3 3 3 common, so 3 3 3 9 27, 1 upon 27, 2 times 3x plus 4 raised to power 3 by 2, plus you can take 2 also common, take 2 common, plus 3x plus 1 raised to power 3 by 2. All right, that pretty much summarizes your basics. Okay. All right, that's it for this lecture. We'll start with the next topic, that will be, after this we'll do substitution. Okay. So basic is a long part, do revise it, it's lengthy, and we have covered basics as well as now AX plus B format. Okay. All right, that's it for today. See you in the next class. Good day everyone. Bye.